Okay, let's figure out how to draw a perpendicular bisector now. Perpendicular bisector. So here is a segment. It cannot be a line. It needs to be a segment between two endpoints. And all we have to do is anchor our compass on one of the endpoints and then loosen your little slider here and adjust it so that your compass will be a little bit more than half, half the length of that segment. And you'll see why in just a minute. So I've already drawn this, of course, but let me go ahead and show you what we did here. So then you draw an arc that, again, you're anchored on one endpoint, and you draw your arc that goes above the segment and also below the segment, and then keep that same distance, that same setting on your compass, and anchor your compass on the other endpoint. And then make sure you remember which hole it was, whether it was the inner hole or the outer hole. In this case, I use the inner one. And then draw an arc of the same distance from your anchor point. And it'll intersect on top and also on bottom with your arc, your original arc that you drew. And now you can draw a line that goes through those 2 points of intersection, and this will be your perpendicular bisector. And what does perpendicular means? Perpendicular means that it cuts it at a right angle, and bisector means that it cuts it in 2. So these 2 segments, this whole segment here to the left and this whole segment here to the right, these 2 segments are congruent with each other. And just like we did for the angle bisector, the reason for that, the reason we can say that this is a a perpendicular bisector, is because we have just created 2 triangles. And looking at this left triangle, we can see that, let's see, what would we do here? These 2 sides here are going to be congruent with each other, because that's the way that we drew it. That's the way that we drew it. And, oh, I guess that's right. I actually would go out here. That makes more sense. I was starting to not sure where we're going. So it's these larger triangles. Okay, so because we drew it in such a way that this distance, this length, is the same as this length over here, therefore we have one pair of congruent sides, and we have another pair of congruent sides because these 2 lengths are also congruent. In fact, it's actually a equilateral parallelogram here. So all 4 of these happen to be the same length. And also because, of course, this third side is shared by the left triangle and also by the right triangle. Therefore, through reflexive, we have a third side that is congruent. Through a pair that are congruent. So therefore, by SSS, we know that these 2 triangles are congruent, and by CP CTC, we can say that these angles up here are congruent. And then as we do that, then what we can do is say SAS and prove that these smaller triangles are congruent. And if these 2 angles are congruent and also make a linear pair, therefore they're going to be 90 degrees, both of them. Okay, so that's a little bit longer to be able to prove using our theorems, but we can prove that these two angles here are 90-degree angles.